So continuing, so negative 18 makes negative x minus 18 0, 0 makes 2x 0. So what we just need to do is consider x values less than negative 18, see how it makes negative x minus 18 and 2x behave. Does it become a positive or a negative number? The same with this set of x values here. What does it do to these two factors and also the set of these x values? Will it make this and this positive or negative? So for negative 18, we consider values less than negative 18, it makes this positive. It makes it negative, and if we take values in between negative 18 and 0, and then negative there as well. For 2x, it's negative for values less than negative 18, negative for values in between negative 18 and 0, and then positive for values more than 0. And then we consider, of course, this is quotient, so we consider the quotient of these signs. Positive divided by negative is negative. Negative divided by negative is positive, and then negative divided by positive is negative. So we now consider what is positive referring to. Of course, that's greater than 0. And we highlight that segment, meaning we will use the values negative 18 to 0. Now, why can't we make use of negative 18 0 as in terms of brackets? Again, to start with, we do not have an or equal to involved in this inequality, so we cannot use brackets, just right there. And more importantly, 0 makes the denominator 0, so we really cannot include 0 in the solution set. So that's the first example. Next, let's try this one. Also referring to an inequality where it's greater than or equal to 0. So the idea is again, put everything on one side of the inequality. So we end up with 5x plus 5 over x plus 1 minus 4 greater than or equal to 0. LCD is x plus 1. So we use that in the inequality. So end up with just x plus 1 over x plus 1 greater than or equal to 0. But then again, this one simplifies into what we call a tautology or an identity. 1 is always greater than or equal to 0. It's always true. So, does that mean there are no restrictions? Of course, there is. You cannot have negative 1 in the solution set because that's the restriction of the original expressions. Third, same idea, transfer everything to one side. This one is referring to less than 0. So as we prepare the table of signs later on, our goal is to look for the negative signs. So here we have factored x plus 3, x minus 1, x plus 2, and x minus 2. So we consider everything in the inequality. What makes each factor 0? Like negative 3, negative 2, 1, and 2. Then just like what we did with the previous examples, we study the signs. For numbers less than -3, it makes x plus 3 negative. And then, of course, the opposite side of that will all be positive. For x minus 1, that's 0 when x equals 1. So everything less than 1 will make it negative, more than 1 will make it positive. X plus 2 is 0 when x is -2. So we have this set of signs. Then lastly, x minus 2 behaves like this. So following the operations, we multiply a negative times a negative divided by the product of this negative and this negative. So we end up with the positive. We end up with the negative here, positive, negative, positive. And since we're referring to less than 0 in the inequality, that would mean we emphasize this set of values as the solution set. So, so that's how we solve equations and inequalities. It's going to be important for the next topic, which is on rational functions. See you in the next video.